Hello everyone, my name is Bogdan Lazar. Unlike all my friends that you saw today, I'm really just starting. I started this project only in August, although the idea is maturing for a while. It's a highly technical problem, and I'm a mechanical engineer by formation. In mechanical engineering, everything is old. Everything that you know about, people are researching it for years, and this applies also to this project. It's the market. It's usually there. It's well established, but there's still a need to innovate. So unlike many other projects that you probably deal with, where the market is not fully defined, you have to create it, you have to define it. For me, the market is there. Now, maybe you heard of computer-aided design. It's a software that mechanical engineers, not only they use for designing their products. I'm sure you use at a certain point this kind of software. It's the most known are CATIA, SolidWorks, and other things. As a definition, it's a complete suite of software. It's not only one part. It's also the numerical simulation part, which it's involved in the same topic of software, which are used to design a product, to test it virtually, and to assist in their manufacturing. When we talk about products, it's not only about the products themselves, but also the tools to make them, the molds, for example. The term computer-aided design was introduced in 1961 by Mr. Douglas. Okay. So the first software, computer-aided design software, appeared in 1963, when actually you might know AutoCAD. It's one of the first commercial software which was made. The first solution was a little bit earlier. Was developed at MIT. AutoCAD was 2D, so you just draw lines and then connect them to each other and build cross-section and so on. Before that, the design was on paper. So they just transported the way the design was done on paper on computer. In '68, people started working in 3D, but not as you know it right now. They started working with complex surfaces, and just they started setting up the mathematical definition. In 1980s, the concept of a 3D object, a 3D solid, was introduced in Cambridge by Jan Braid. It's so-called the boundary representation. Is the model of choice for all the CAD systems at the moment. There are two geometric models which are used by all the CAD software at the moment. In '88, people started working on how to build this object. So the so-called parametric feature-based design paradigm was developed by that time Pro Engineering. Now it's called PTC Creo. They actually record the history of building the object, and you can later on modify it. It's the most widely used. In 2007, some people thought that that's too complicated. Maybe we can simplify it to work directly, not to keep the history, just modify certain features. And there's a new startup which was created and in 2007 made this year it's called Space Claim. Now in 2014, people, of course, they think about clouds. So there's a new startup coming out by one famous guy who actually developed SolidWorks, which was one of the most successful startups by 1998. I don't know if you know the guy. It's a nice history about him. Maybe you heard of the blackjack team from MIT. There was some students which started to play blackjack in Las Vegas. They made a few millions. One of the guys founded SolidWorks. And he sold it through IPO to Dassault System, which is another huge corporation, by 350 million in 4 years after he founded. Now he's working on something else. He raised 48 millions. We have to see what's coming. Now, just to give you an idea about how the market is, the numerical simulation market, it's a little bit different. The principles were set in the 50s. The first open source libraries appear in the 60s, and the market is dominated mostly by open sources. There are commercial developments. In the 70s, it's ANSYS, which is now it's a well-established ANSYS corporation. In 78, to attack nonlinear simulation problem, Abacus was developed by Dassault Systems. They are not really integrated, although certain CAD modules they have some simulation functions, but you cannot really work with both of them in the same environment, and that's because the way they represent solids is different. A summary of the market, it's a huge market with $8.3 billion estimated in 2016 for the CAD. Is still growing for about 6 to 8% annually. The FEA, it's very difficult to estimate. There are no reliable numbers. The market growth, it's expected, it's actually higher for simulation because the computer power is getting higher and higher. Finite element simulation. It's dominated mostly by big players. So the software packages are huge. They are years of development involved, and it's very difficult to attack such a market. During my postdoctoral assistantship at EPFL, I was given the task to try to simulate machining process, which at the moment is not possible because of the limitation in the fundamentals of the CAD system. So that's how we started finding a solution. The solution would be to change the way solids are represented in memory so that we can link it to the simulation rather easily. So we propose a new solid modeling representation, which, well, in my opinion, will be another step like switching from 2D to 3D, because we can introduce functional design. So we don't design only the geometry, we design the function of a product, how that product will move, behave, and interact. So this is what we're proposing. Now, since we just started, what we actually did in the last month is to qualify mathematically the new model as a valid solid modeling representation technique, to file for an IP. And at the moment, we're building a business scenario and looking for seed money to be able to provide the prototype. We have a proof of concept. And well, that's about me. I just wanted to let you know that there are different projects in the startup business. I'm still having troubles how to attack such a market, because you cannot just go on and compete with a product as CATIA has. So we'll have to find probably in the next few months a niche that we can attack, like a minimum viable product. So we're still working on that. Who to target? The good thing is that I consider that I know the market very well. I'm a user of this kind of software. I've been working for companies that they they build their business on designing things using this kind of software. I know how difficult it is to at the company level to make a change of software, because you have to take care of all your history, legacy projects, and training of the people and so on. I know the difficulties. We'll have to find a way to attack it. I have more detail. There are more in the financial and so on. I don't think it's important. Since it's rather late, maybe I will cut it short and expect some questions for you. By the way, I'm looking for some team members, some good programmers, because one of the ideas that we're discussing with some potential investors is to open a development office in Romania because it's cheaper. So if you know somebody who has experience in computer graphics, I'm willing to get into contact with them. Thank you. No questions?
Is it possible to see the proof of concept? Or,
yeah, I don't have it with me because
YouTube movies of it or something. Yeah.
We kept it secret for a while because we just 2 weeks ago we filed a patent. So we are working on something that we can show. However, well, it's a prototype software, so I cannot just take it and put it on any computer. We use a lot of third-party library. We have to make a movie, but it's a bit too early for that. It's yeah, it's like a CAD software. We don't have all the tools. It doesn't look so nice at the moment, but we believe that we will be able to do more interesting things with it. No, because actually where the change lies, it's in the core library of all the, because actually SolidWorks or CATIA, there are only 2 commercial kernels. One is owned by CATIA, one is owned by Siemens. And for example, SolidWorks uses the kernel from Siemens. And we'll have to change that throughout. Plus, using this new representation will trigger a lot of changes in the way you design a product. So there will be new functions normally. However, probably as a first product, we'll use the same, roughly the same interface, because we don't want the same type of interface. We don't want to do such a dramatic change. I don't know if the clients will be ready for that.
And you don't want to redo everything?
Well, the problem is that we have to redo quite a lot of things. That's the major. So will be a huge development of effort. Now, there are many new things that we can do with this. Many new functions like functional design. This is one, but actually the way you design a product, the geometry, it can be dramatically changed.
Yeah, but in which sense it benefits the user? It's just different, or it's more efficient? Or?
Well, first, you don't need 2 software. You won't be needing a simulation, so you have them all at once. They will be linked. Yes. You can do simulation and see the results and modify both the geometry in the same environment. Second of all, you can put constraints on physical issues. So I want a part to deform a certain amount. At the moment, you can say you can constrain the thickness of a beam to a certain dimension. You cannot impose a certain deflection. You cannot impose a certain part to move by certain angle or by a certain speed or something like that. We will be able to add that. It will bring. This is yet to prove that we can build the product faster. But more importantly, it will be a product that you can see how it will work in a CAD environment. So meaning that you will probably remove any product development iterations. So you don't need to build so many. Eventually, you have to build a prototype, but maybe you won't be needing 10 cycles, but 1 or 2 will be enough. According to our plan, it will take at least 5 years on the market. Some demonstrations. So the plan is for the first year to build some user cases. We're already in contact with some potential customers. It will be a software which the client will not be able to use because it will be, let's say, by comments it will work, but we can show that we can do something. Then I would say another 2 years of development to actually do a beta software that we can give to people for testing, and maybe 4 years to put it on the market.
You did it already more than working with primitives, with geometric shapes. I understand.
Yeah.
Would be interesting to see.
In what stage of patenting are you? You said earlier that you're filing for a patent.
Yeah, we filed for the patent a few weeks ago. Now, till they get approved, it takes about 2 years or something.
Hopefully.
Yeah.
It takes 18 months until they start to approve it.
Well, you can ask for a priority review. There are different ways. Depends on how many comments they have or revisions or.
Did you file the patent in Romania or
No, worldwide.
worldwide?
Worldwide.
PCT application or US United States application?
No, PCT.
PCT.
The beginning it doesn't cost much.
Yeah.
Yeah, I have one too.
No, but we had to release the patent. What happened? The boundary representation, the initial model, all the CAD software used, it was again developing academia. The guy that they just published. So there was no. They built the first prototypes and then they licensed the first libraries to Siemens, for example. But there's no patent on it. So it's afterwards everybody could copy. Then that's why there are so many softwares built on the same principle. So now, since we want to raise some money to build a development, we had to file a patent to protect the investor. It's not necessarily for us. We're gonna also do a publication.
Can you give an example of some niches? Like you said, you have to identify a niche to focus on in the beginning. What kinds of, because it seems like there's hundreds of possible.
So, from my point of view, there are many people using the CAD software in a company. There are the design department where you have senior, juniors, and you have the draftsmen, which are mostly helping around. They are used also in the marketing department for making renderings and so on. So that in a big company, there are several places, and R&D. There are several places that they use this. What I was thinking is, because they are all integrated, they are also integrated with the project lifecycle management tools in the same CAD software, with manufacturing tools, because each part you'll have to build tools for it, to machining plan and so on. What I was thinking to start with is to go at higher level, the people which do the early stage design. And then, for example, not even do the drafting part, because the drafting part is done by juniors. So that was the idea, and ideally to target rather small companies which are easier to change. As for example, BMW, probably they will evaluate the software for a few years and then decide to change after they will have 1,000 requests.
Okay, I didn't know you were looking for graphics programming skills. There's several contacts that we can talk to this afternoon around Cluj. I know that there's one research group here that does, I think it's a different area, because they do like computer vision and image processing, but that's I think it's different.
If it's 3D, it's still helpful.
Okay.
Because I've been working with a lot of students and programmers in our lab, and it's very difficult to find somebody which is good at solving three-dimensional problems, having a three-dimensional vision. So that's why we're looking for somebody.
And there's also a research group of Professor Daniela Professor. I don't know if somebody here is so they should talk.
Actually, it's not me, it's my colleague who will be present, but I came to
Sure,
see the presentation.
we should talk. It's probably means you have students or you collaborate with software companies maybe, or?
Well, actually, we don't work so much in creating new software. We work on applying that software for process improvement, for product development, for things like this. That's our job, let's say. But it might be interesting to have collaboration from a different point of view. Why not?
Yeah, sure, certainly.
User experience. And then for the software development, there's the IT cluster. And I know the guys at the IT cluster, they collaborate with the university a lot. And I mean, if there are people, they know them. I mean, they know everybody. So in this software ecosystem, which is much more active than the hardware ecosystem.
Or we can explore some contacts, but any are appreciated.
So when do you think that it will be best suited for you to contact a bigger firm to invest in your idea? After or before the patent will come out?
Well, I cannot wait 2 years until the patent. I think it's a waste of time. So how I see the things, I calculated we need around 400K to do the use case. Some use case scenarios that we can demonstrate for certain clients. And we're already in contact with certain potential clients. We are negotiating an Inogram from EPFL, which is 100K. There might be some venture kicks and so on that can build up, but we're still missing around 200. So what I think is to find the business angel or early stage investors. Now I'm following leads in the States. Actually, the guy who founded SolidWorks is very interested in finding out more about a new solid modeling representation, as he also believes that it's the next generation of softwares. So I hope that if he managed to raise 48 million, maybe he can give us a business angel who can invest a few hundred. Once we have the case study, would be much more easier to go to some proper venture capitalist. I wouldn't go to a big company just yet because, for example, Dassault System, they have their own their own source of revenue is coming from this kind of software, and they have a nice business, it's working. There are no threats on the market. Why would they change their whole software? If they get the chance to be involved in this, they will probably keep it on low development until, I don't know, the market is ready or something like that. They have no motivation to do such a change. So from the moment, I think I will keep away from Siemens or Dassault system. But well, we never know. I see them as potential exits once we have the product on the market.
I think this is a question. This is one of those very common misconceptions in the academia in Romania, that everybody's focused on the date of granting the patent, whereas the most important date is the date of filing. And then from that date, you can talk to people, you can negotiate, you can sell, you can license it, you can whatever. You can do everything you want, starting from the date where you file it. And that's why you said that until 2 weeks ago, you didn't talk to anybody. And then you filed, and now you can show it, because then you're protected. Of course, there's always the risk that you will get rejected. But I don't know if you are more or less not completely, off the mark. I mean, the chances are not huge. I think most of the time you can change claims and change and adjust, and eventually you will get granted. Maybe you will get granted differently than what you filed, but something will get granted. But by that time, usually, if you don't have a partner or business or something by that time, that means you're way too late and too much money, too much time.
So as I see, the patent strategy is that if you have an idea to file it as a provisional patent, doesn't cost almost anything. Well, for a few hundred Swiss francs, I think it was the PFL who covered it. And then you can start talking to people and feel somehow protected. Anyhow, for such a topic, and not only, yes, for many technological problems, the idea is so complex that a business person will not make too much sense out of it. So you should be scared of sharing it maybe with some other technical persons, which they are backed up by some business person. But just to talk to another business guy, I feel rather safe. Well, it's always best to do it after you have a patent filed.
Publish your paper too.
Yeah.
Publish too. So you file it, publish it.
Because so all the developments so far were at EPFL. Everybody was eager to publish. For 2 years I'm holding them. Don't publish anything. It's my professor was stressing me with the patent. I file it. I want to, and eventually he missed the deadline. So now probably we'll do the publishing in a few months. So. But last month, yeah, he was calling me. Is the pilot patent ready? He was calling me every day.
You can submit your paper if it's accepted.
Actually, yeah, it's confidential, but the submission date it's written on most journals.
Yes. But
And
the invention is, if it's a title, then it's a details.
So I think submission is confidential. It's
Yes.
the publication that is
Yes.
publication, the date of publication. So if you submit it, you can tell them, look, don't publish it in this number, publish it next month because I'm filing next week, and they will delay. They're happy actually.
But
There's more room.
technically, the fact that you send it for reviewers is disclosure.
Yeah.
So, well, now,
But not legally.
yeah, it depends on many issues. So we wanted to be safe.
Yeah, just very quickly, first of all, thank you all for being here. And I think this has been an exercise in entrepreneurship in which the product that we're trying to sell is entrepreneurship, you know. And so this is a customer development exercise. So I hope that, you know, obviously this is a tough market, you know. in academia in general, and maybe in Romanian academia in particular, that the whole idea that it's basically most
people here, if I went to a random professor or some random a lecturer in the university, and I asked them, hey, you know, are you interested in entrepreneurship? And the answer is the 90% answer of any client to any product is, what's in it for me? Why should I care? I'm doing fine, you know. I got grants, I got publications. What do you want from me, you know? And not only that, but actually it's like, yeah, it's actually going to hurt my activity. Well, it's negative. It's not. I mean, people are going to. For example, I was talking to one professor who's doing energy stuff. Actually, we might meet him a little bit later, and he's like, "Well, I've already lost a few of my students because they got recruited. My best scientists, they got recruited by a company that pays them a lot more than I can pay them. And so why should I meet with entrepreneurs? Actually, they're stealing my best people, you know." And to him, it was like, "Yeah, you know, we tried to do business. It didn't work very well." And then you have to explain and everything. So, and I tried with my team, Medorian and my other colleague, Elena, we were trying to apply some of these principles, you know, like lean startup and well, the business model canvas we didn't really use, but we can use it to just for this project itself, you know, to see what are the needs of the customer, which is you know, and how we should present, communicate, what's the value proposition of entrepreneurship itself. So it's a lot of fun. But, you know, I would have wished that there was more interested people here, but you know, we start with some people, and then maybe after 6 months, a year, there will be more. And I think if there's just only one person that, as a result of maybe our project, becomes an entrepreneur, becomes a success story that inspires other people, that means it was a successful project. You know, just one success story from Cluj or from Bucharest or from that actually starts the business and manages to actually apply technology. That means it's something. You start it, and then you have 2 people maybe, and then you have 4 people, and then maybe after 10 years, you know, it took 20 years in Lausanne. You know, they started in 1980s, and now they have a very active ecosystem. But back in 1988, it was exactly like here. You know, so. All right, thank you very much, and have a bon appetit. You know.